Okay, I'm not going to answer all of these with this recording, but I will look at two of them. I'll probably do this one and this one to give you the idea. I have a feeling there might be a typo here on this one. Horizontal asymptote at y equals perhaps -6, but I'll leave that to you to figure out. So let's look at board 2, where we're talking about the fact that there's a 0 at 3, a vertical asymptote at x equals 4, a horizontal asymptote at y equals 4/5. Okay, so we'll start with, for there to be a 0 for a rational function, the numerator has to equal 0 at that number. So that means x minus 3 has to be a factor of the numerator. So zeros occur when the numerator is 0 of a rational function. We have a vertical asymptote when the denominator is 0. So we want a vertical asymptote at x equals 4. And I can see I forgot to put in the vertical asymptote here. That's supposed to be a graph of that function. And we want a horizontal asymptote at y equals 4/5. So there's a horizontal asymptote at a number other than y equals 0 when the degree of the numerator equals the degree of the denominator, which is already the case. So if I just put a 4/5 here, I could rewrite this as 4x minus 12 over the quantity 5x minus 20. And for you to see why the horizontal asymptote occurs at 4/5, we might divide every term, numerator and denominator, by x, and we get 4 minus 12 over x over 5 minus 20 over x. And as x approaches infinity or negative infinity, these fractions approach 0. So if I ask the question, what's f of 1 million? I'm going to get very close to 4/5 because these fractions approach 0. So that's why we have this horizontal asymptote here at 4/5. Okay, on board 3, let's look at this one. There are no zeros. That means the numerator never equals 0. You could put a constant term up here, 7 or 1, but the numerator never equals 0. There's a whole at x equals -3. That means there's a factor in the numerator and the same factor in the denominator. So really, as x approaches -3, but it's not equal to 3, these factors cancel out. And here's the whole for the function that I created. And we have a vertical asymptote at x equals 1. That means we have this factor in the denominator. And a horizontal asymptote at y equals 0. There's a horizontal asymptote at y equals 0 when the degree of the denominator is greater than the degree of the numerator. So if we picture these canceling out, as x approaches infinity, we're getting numbers like 7 over infinity. So it's approaching 0. So there is a horizontal asymptote at y equals 0. So this is one example that satisfies these requirements. You could make that 7 any number you wanted to, really. Okay, there you go. Back to board 1. Just a comment here. So we'll have zeros at -1 and 3. Means there's x plus 1 and x minus 3 in the numerator, and probably an x, just a plain old x in the denominator, because x could not equal 0 in that case. Okay, so that's enough comments on these problems. Hopefully that's enough for you to figure out the rest of them. There you go. Hope that helped. If you have any questions, post a comment.